Today we will learn about how to control the temperature resistance of an heating furnace, and secondly we will know construction principle operation of arc furnaces. If you remember, in the last class we have learned different types of electrical heating methods, namely resistance heating, arc furnace heating, induction heating, dielectric heating. Under this we clearly learn about how a resistance heating will be used in furnaces. In a furnace, to melt the iron ores, different temperature control methods are required, because at one particular temperature we cannot operate, because different materials will have different characteristics. Therefore, it is highly necessary to control the furnace resistance so that the temperature of the furnace can be controlled. What are the methods of temperature control resistance? There are various methods, namely you can see with this slide, temperature control of resistance heating. First one is by varying supply voltage. We can control the resistance of the temperature by varying the supply voltage. Second, by varying the resistance of elements. By keeping number of resistance elements, we can vary the temperature. Periodically switching on off the power supply. So we will know in detail about these methods. The first one is we can control the furnace temperature by varying the supply voltage or apply voltage, or by varying the resistance elements, or periodically by switching on and off the switches. We can also vary the furnace temperature. The first one is by varying the applied voltage. By varying the applied voltage, each furnace unit should have a generating station, so that if we know the generator principle, construction and operation, by changing the field current to the generator, by changing the field current, the output voltage of the generator can be controlled. So once we get the output voltage at different stages by changing the current of the field current, so we can supply different voltage to the furnace. So by supplying the different voltages to the furnace temperature can be controlled. So here the furnace unit should have a separate generator, where in the generator the field current has to be changed or varies. By varying the field current, the output voltage of the generator can be varied by supplying the different voltages to the furnace. So the temperature of the furnace can be controlled. This is the first method. Temperature control by supply voltage. By variable supply voltage, by auto transformer or induction regulator, by series impedance. So we can control the temperature of the furnace by supply voltage. The supply voltages will have three types. One is by variable supply voltage, by auto transformer or induction regulator, by series impedance. Out of these three, by variable supply voltage to the furnace can be supplied by having a separate generating unit. By controlling the field current, we can supply the variable voltage. By supplying variable voltage, furnace temperature can be controlled. This is the first method. And other than this, the supply voltage also can be variable supply voltage also can be supplied to the furnace by using the auto transformer, induction regulator, or by using the series impedance or regulator in series with the supply voltage. So now one by one let us see. Auto transformer. We know the auto transformer principle. Auto transformer will have only one winding, and that winding, part of the winding is connected to the supply, part of the winding is connected to secondary. In auto transformer, a variable voltage can be, we will get the variable voltages by using the auto transformer. So, by connecting the auto transformer in series with the furnace unit, we can supply the variable voltages by controlling the regulator of the auto transformer. So, we get the variable voltage at the furnace, therefore, a variable temperature can be get near the furnace. So, you can see this figure. So, this is the auto transformer having only one winding. Part of the winding is connected to the supply of V volts, and secondary winding you will have a tappings 1, 2, 3, 4, and this tapping system is connected in series with the furnace resistance, or this is the furnace unit resistance furnace. So, to control the temperature of this furnace unit, it needs the different voltages, that is potential difference across this point to this point, that can be achieved by adjusting this tapping system. So, this variable supply voltage will be given to the primary, and in secondary by adjusting the tapping system, a variable voltage can be achieved across the furnace. This variable, by adjusting this variable voltage, the furnace temperature can be controlled. Other than auto transformer, you can also connect the induction regulator in series with the resistance element. Now, this is single phase induction regulator. This is a regulator having primary winding and secondary winding, compensating winding, and the secondary winding is connected in series with the furnace. The supply voltage is V1 volts. This is the V1 volts is supply given to the primary, whereas secondary is connected to the furnace in series with the furnace. The output voltage is V2. So, now by changing the primary voltage, generally is called as the rotor voltage, the EMF in the secondary can be changed. By changing the secondary EMF, the furnace voltage can be controlled. So, by changing the furnace voltage, the temperature also can be changed. And the third method is series impedance control. So, we all know, we already doing this in our laboratories. What is an impedance? Impedance is nothing but a rheostat connected in series with the circuit. Now, the circuit is here a furnace or furnace resistance. So, now the impedance, or generally it is also called as a choke, is connected in series with the furnace resistance. Now, this is the heating element of the furnace. Now, a supply is given in series with the impedance, so that whatever the voltage you are giving, that will be dropped at the choke itself or impedance itself. So, by dropping the voltage, only low voltages can be applied to the furnace by adjusting this tapping system. The arrow marks or dotted line shows the tappings. These tappings can be adjusted by rotating the tap changer system. By changing the tap changer, low voltage or high voltage can be achieved near the furnace. By supplying the low voltage or high voltage, the furnace temperature can be controlled. So, now the voltage is dropped only in the choke and low voltage will be given, and if furnace needs the high voltage, then the tapping system will be kept directly to the line by avoiding the series impedance, so that full voltage can be achieved to the furnace to get the full temperature of the furnace. Therefore, these are the various systems by using the applied voltage, the furnace temperature can be controlled. This is the one method. The other method, the furnace temperature also can be controlled by using the number of heating elements. If the heating elements are connected either in series, number of heating elements are connected in series or connected in parallel or series parallel, or the connection will be made into series or into delta or from delta to star. By converting these, the voltage also can be changed, therefore, the temperature of the furnace resistance can be changed. Now, by varying the number of heating elements, how the temperature is controlled can be seen through this slide. Temperature control by varying the resistance of elements. Temperature control by varying the resistance of elements. 1. By varying the number of heating elements, that means by varying the number of, that means either increasing the heating elements or by decreasing the heating elements, the temperature of the furnace can be controlled. Number 2, by changing the arrangement of heating elements. Arrangement means either you can connect the series or you can connect in the parallel or you can connect in any manner. By interchanging the connections also the temperature of the furnace can be controlled. Now, by varying the number of heating elements means the unit furnaces all they have to be connected either in parallel or in series. So, by connecting all this into a common switch or individual switches, by closing the switch, so we can control the or we can have a number of heating elements either in series completely all the furnaces or some in series or some in parallel or all the furnaces are in parallel. So, we can have a number of heating elements either more or less. By having a heating elements more or less, the temperature of the furnace can be controlled. Now, see this diagram. Now, these 4 are heating elements 1, 2, 3, 4 are 4 furnaces, they are connected in parallel and each furnace is or each heating resistance element is connected to an independent switch, that is S1, S2, S3, S4. So, these 4 are independently controlled by these heating elements and finally, they are connected to the supply. So, in this way we can connect the heating elements. Suppose we want a low temperature, then opening S1, S2, S3 we can close the S4 switch. So, only one heating element will be there, therefore, the voltage will be divided into only particular heating element instead of divided into so many heating elements. So, if we want to increase, then put on the switch 2, again further increase, put on the switch 3, like that by increasing or decreasing the switches into the line or in the circuit, we can control the furnace temperature. This is the one of the method used in the furnaces to control the temperature of resistance. Number 2, here the switch 1 is connected to 3 elements, this is 1, 2, 3 blue arrow marks. Switch 2 is connected to another 3 elements 1, 2, 3. So, therefore, total 6 elements are connected to 2 independent switches. So, now by connecting switch 1 or making on switch 1, so only 3 elements are in the circuit, other 3 are not there. So, if we want to reduce the temperature, then close only switch 1 and do not close the switch 2, only particular number of heating elements will be in parallel, therefore, the applied voltage will be divided into particular heating elements. Therefore, by changing the voltage or by applying the reduced voltage, the furnace resistance value will change and therefore, the temperature also will change. And other than this, you can see here R1, R2, R3, R4, 4 heating elements, they are connected in parallel and connected to the supply. If the connections are made like this, the heat developed by these resistors or heating elements is equivalent to the rating of furnace. Here the rating of furnace is equivalent to the heat developed by these 4 resistances. Now, instead of connecting all 4 in parallel, and we can connect these into 2 paths, that is R1, R2 in series, R3, R4 in series, and finally these 2 paths are connected parallel across the supply voltage of V volts. Therefore, by connecting so, the applied voltage V, supply voltage V will be divided into 2 equal paths, 2 equal branches, that is V by 2 across R3, V by 2 across R4. So, by doing so, the heat will be equivalent to 1/4 of the furnace rating. So, here heat equal to furnace rating, Q is the furnace rating, H is the heat developed by the resistive elements. So, here if you do the connections like this, the heat developed is equivalent to the furnace rating. If you are making 2 parallel branches, the voltage will be divided into half of 50-50%. Therefore, the heat developed is equivalent to 1/4 of the rating of the furnace. The next one is, if 4 resistive elements are connected in series, therefore, the voltage supply voltage will be divided into equally 4 among the resistors. Therefore, each element will be having a voltage of V by 4, V by 4, V by 4 and V by 4. So therefore here the heat will be equivalent to the 1/16th of the rating of the furnace. So these all these calculations we have already learned in the second year or in subsequent classes, how we will get 1/16 Q and all. So here only our understanding as per our subject concern, we have to understand if all the 4 elements are connected in parallel, therefore the heat produced by the 4 elements is equivalent to the rating of the furnace, or if they are connected in 2 parallel paths, so the heat will be reduced to 1/4, and if they are connected into the parallel, the heat is equivalent to 1/16th of the rating of the furnace. So this is the one way of controlling the furnace temperature. The third method is the temperature also can be controlled by using the periodically switching on and switching off the supply. What do you mean by periodically switching on and switching off the supply? So that means by making the switch on and off, also the temperature of the furnace can be controlled by this method, but this method is used only for small furnaces. It cannot be worked out for a big furnace, right, furnaces. So here by switching on, the temperature will be raised to the required or desired value. Once by switching on the switch, the temperature goes to the required or desired value, then immediately you just switch off. Once you switch off, even then also the voltage will be raised for some time, then slowly it falls and comes to the reduced level. Once it is reduces, immediately again you make a switch on, therefore again the temperature goes up. So therefore by making switch on and off, we can control the temperature of the furnace. For example, you take the thermostat. So whenever we need the temperature, you just switch on the thermostat, therefore the temperature rises or keeps at required level, and once it reaches to the required level, immediately you close the switch, that you put off the switch off into the off position, therefore the temperature can withstand for some time, slowly it falls down. Once it falls down to a predetermined value, again you make switch on, therefore the temperature of the furnace can be controlled. So you can see, so temperature control by periodically intermittent on off. So in this method, when supply is switched on, the temperature reaches to the required value. When supply is switched off, the temperature reduces beyond desired value. That means when switched on reaches to the required value, switched off reduces to beyond desired value. Even after switching off the supply, the temperature rises for some time and then decreases. When the temperature reaches to predetermined value, the supply should be again switched on. So once the switch off, the supply remains for some time and decreases. When it is decreases to the predetermined value, again you put switch on, therefore it goes to again required level. So this method is used only in small furnaces. So these are the various methods of temperature control of resistance. The first one is by using the applied voltage. That means a variable voltage can be applied to the furnace. How we can apply the variable voltage to the furnace? By having a separate generator unit, or by using an auto transformer, or by using an induction regulator, or by connecting a series impedance in series with the circuit. So these are the 4 methods we can apply the voltage at different stages, therefore furnace temperature can be controlled. The second method is by periodically changing the number of heating elements, or by varying the number of heating elements, or all the heating elements should be connected in parallel or connected in series, or parallel and series. We can incorporate number of heating elements, therefore the temperature of the furnace can be controlled. The third method is used only in small furnaces, where by using periodically by closing the switch in on position or opening the switch in off position, that is by using the thermostat, we can control the temperature of the furnace resistance. So these are the various methods are employed in industries to control the temperature of furnaces. So, next topic is arc furnaces. If you remember in the last class, when the current is passed through the resistive elements or through the resistance, when current passes through the resistance, the heating effect takes place. The heat will be evaporated. So, the heat is nothing but in a temperature. By using that temperature, we can melt the solid items into liquid items. So, this method is employed in the furnaces. Other than this also, that is another method where instead of using the resistive elements, by producing the arc or by establishing the arc between the charge or metal to the electrodes, we can also convert the solid material into liquid material. So, this can be employed into the furnaces. First of all, let us know what is meant by a furnace. A furnace is nothing but a melting device where you can use all the iron scrap material into the furnace and convert into the liquid pool. So, that is called that unit is called a furnace. Now, in the furnace, when you supply the current through the electrodes and the arc will establish from the electrodes, and once the arc establishes, lot of radiation takes place, heat radiation takes place. By using that radiation, the metal which you have put in the furnace can be converted into the liquid stage. So, these are nothing but an arc furnaces. In arc furnace, you will be having a closed chamber, either they are made of spherical or cylindrical. In a closed chamber, if you see inside, electrodes will be mounted. For single phase, 2 electrodes will be there. For 3 phase, 3 electrodes will be there. Generally, these electrons are made of copper, graphite or Soderberg. Only these 3 electrodes are used because they have very good electrical conductivity and they have infusibility. They will not be fused out at higher temperatures and the mechanical strength will be very high. So, by passing the current through the electrodes, the arcs will be established. How the arc will be established? By giving the higher voltages to the electrodes. But arc can be established by supplying the high voltage, but by supplying the low voltage also arcs can be produced. But generally in the industries, momentarily the electrodes will be short circuited. By short circuiting the electrodes, the arcs will be established. Once the arc establishes, it starts radiating out about 3500 degrees centigrade. You know 100 degree temperature is the boiling point of water. At 100 degree temperature, you can see what is the temperature of the water. But imagine at 3500 degrees centigrade, we cannot see with our eyes that temperature. So, by applying these 3500 degrees centigrade in the furnace, the material which you have put in the furnace chamber entirely converted from solid state to liquid state. So, we can see one by one how the arc furnaces will work. So, first let us come out some important points. Electric arc furnaces, a very high voltage is required to establish an arc across the air gap of the 2 electrodes. Arc can be established by short circuiting the 2 electrodes momentarily, but generally in the industries only this principle will be used. Arc can be established by short circuiting the 2 electrodes momentarily and separates them immediately. Arc furnaces are 2 types, direct arc furnace and indirect arc furnace. Before going into the arc furnace, let us know some important points about the furnaces. In furnace, electrodes are made of carbon, graphite or Soderberg. Only these 3 types of metal will be used. Carbon and graphite are popular on account of electrical conductivity, infusibility, chemical inertness and mechanical strength. So, because of these characteristics, that is conductivity, infusibility, chemical inertness and mechanical strength, only these electrodes are used in the furnace. carbon electrodes are used for small furnaces, but carbon electrodes are used only restricted for small furnaces. Graphite electrodes are used for large furnaces. Arc chamber has a suitable acid or basic refractory lining supported on a metal framework. The total chamber of the furnace is made of refractory material supported on a metal framework. Electrodes projected through the top or sides of the chamber. Electrodes are projected through the top or sides of the chamber, arranged for easy replacement and adjustment. Charging doors and top holes for pouring charge are provided. For putting the scrap material, charging doors or top holes are provided. These are the some important topics of the arc furnaces. So now let us see through this picture how the arc furnace will function or melts the iron ore material into liquid stage. So in arc furnaces, this is a direct arc furnace. There are two types of furnaces, direct arc furnace and indirect arc furnace. So in direct arc furnace, this total is a closed chamber, opened only at two places to insert the electrodes, and this is made of cast iron. The outer one is made of cast iron, and the inner one, this dotted line, is nothing but a refractory lining. What does mean by refractory lining? Refractory lining means the inside chamber is made of brick masonry or some China clay sand, China clay material. By using these materials in the furnace, the heat developed into the furnace cannot be escaped into the atmosphere. Suppose the outer frame is made of cast iron. If heat is produced in the furnace, the heat easily evaporated into the atmosphere. So heat should not be evaporated into the atmosphere. Complete heat has to be utilized to melt the charge. So therefore the inner lining will be made with a brick masonry. The brick is special type of brick which does not evaporate any heat into the atmosphere. And inside the brick masonry again some chemical coating will be done so that no heat should be escaped into the atmosphere. Now you can see this brick masonry, the yellow line is nothing but a chemical coating, and these dots are charge or scrap iron material are placed in the furnace, and these two are electrodes made of carbon or graphite, and finally the electrodes are connected to a supply. So this is connected to a single phase supply, where in single phase supply we will have two electrodes. If it is a three phase supply, we will have 3 number of electrodes. Now by connecting these electrodes to the supply, so if you go and increase the supply, the voltage will be, low voltage will be applied and high currents will be used. So by using, how you will use the high current? Here the transformer winding will be controlled such that it has to supply low voltage and higher currents. The voltage rating of the furnace will be about 100 volts to 150 volts only, but the rating, the current rating will be in kiloamps. By supplying kiloamps of the current to the electrodes, and arc will establishes, but before supplying the current, momentarily they will be short circuited. Once they are short circuited, so the current will be established and the current will be flowing to the charge. So once the current is flowing to the charge, electromagnetic forces set up, and due to this electromagnetic forces a stirring action is inherent. What does mean by stirring action? Stirring action means a uniform heat will be developed into the furnace. So by producing the uniform heat, the complete scrap material will be melted into liquid pool. The advantage of direct arc furnace is the current will be flowing to the through the charge. When the current flowing through the charge, electromagnetic forces set up, therefore a stirring action takes place and complete solid material will be converted into the liquid stage or liquid pool. So these furnaces are also called as the baby arc furnaces. Now in these furnaces, if 3 phases are, 3 electrodes will be there. So momentarily these 3 electrodes will be short circuited and separated immediately. Therefore the arc establishes, and once the arc establishes, the temperature will be induced or the heating will be produced from the arc. The heating will be in the range of 3500 degrees centigrade. So the material will absorb that heat of 3500 degrees centigrade. Immediately the material will be, or the solid material will be converted into the liquid pool. So in this way the furnace will works, and these direct furnaces are used in iron industries, where the iron material will be melted into liquid stage, and these furnaces are very easy to control, very simple operation. So we have to see some more points on the direct arc furnace. Direct arc furnace, electric supply is given to 2 electrodes. 2 arcs are established, 2 electrodes are there, therefore 2 arcs are established. Heat is developed due to radiation from the arcs. Single phase arc furnaces called baby arc furnaces. 3 phase supply is employed for large capacity furnaces. 3 electrodes are placed at the 3 vertices of an equilateral triangle. Suppose in 3 phase 3 electrodes will be there, they are connected to a transformer, where the transformer will have 3 vertices of an equilateral triangle, because it is connected into delta connection. Current flows directly through the charge. So it is very simple, easy to control, and used to produce steel. Very simple, easy to control, used to produce steel. So this is the way how the direct arc furnaces will work. So these furnaces are employed only in steel industries. Direct means the current flowing, or the arcs are nothing but flow of charge is flowing into the scrap material or iron material. So therefore electromagnetic forces set up, and due to this the uniform heating takes place, and the material will be converted into solid stage into liquid pool. The next method is indirect arc furnaces. In indirect arc furnaces, instead of mounting electrodes vertically, the electrodes will be mounted horizontally. When these electrodes are given a supply, the arc establishes between the 2 electrodes, and once the arc establishes, the radiation which is coming from the arcs is sufficient to melt the iron material. But in this method the temperature is very less. The temperature is very less because the currents are not directly flowing into the charge. Therefore these furnaces are restricted for only small rating. Now let us see through this diagram how the indirect arc furnace will function. This is the indirect arc furnace. You will be having 2 types of indirect arc furnaces. This is a closed one, either spherical or cylindrical type of mounting will be there, and this red one is the electrode, this is the electrode 2, and this yellow one is the arc establishes, and these are placed horizontally above the materials or charge which has to be melted into liquid stage. Again this complete cell is made of cast iron and lining with a refractory material, and some chemical coating also will be done inside, so that the heat should not be evaporated into atmosphere. Now when the current passes through the electrodes, therefore at one particular temperature the arc establishes. Once the arc establishes, the radiation which is coming out from the arc will be about 2000 centigrade to 3000 degrees centigrade. With that temperature, the material which is placed inside the furnace will be melted into liquid stage. So here the current is not passing into the material. Therefore since current is not passing into the material, so stirring action does not take place. So once the stirring action does not takes place, that means the material will not be uniformly heated. So if it is not uniformly heated, then the complete material will not be converted into the liquid stage. Therefore, these indirect arc furnaces will be mechanically rocked. A rocking action takes place. What does mean by a rocking action place? So under the furnace, a grinding wheels will be incorporated, and these grinding wheels will be moved here and there by the connecting to an electric motor. When supply is given, electric motor starts working. So electric motor, the mechanical force is converted through the gear system to the grinding wheels or movable wheels. So once the material converted into the liquid stage, or conversion takes place from liquid stage to the solid stage into the liquid stage, so the grinding wheels try to rotate the chamber this side and this side, therefore a stirring action takes place. Since this is done by the mechanically, by connecting the electric motor, these furnaces are called mechanical rocking furnaces. Mechanically rocking furnaces. So this is not there in the direct furnace, because currents flows through the charge and entire material will be converted to liquid stage, because here the arc, from the arc whatever the temperature is coming out, that temperature is absorbed by the material and converted into the liquid stage. Since there is a no stirring action, so mechanically stirring action will be provided by connecting the grinding or roller wheels underneath the furnace. So you can see here, so this is the indirect arc furnace and the charge is placed, and this red one are the roller wheels, they are connected finally to electric motor. So these wheels will be rotating, so that this will be tilted here and there or moved for some distance from by tilting. So the material will be stirring action will be taking place, therefore the entire material will be converted into the liquid form. So let us see some more points about the indirect arc furnaces. Arc exists between two electrodes. Heat is developed in the charge is purely by the radiation from the arc. Heat is developed in the charge is purely by the radiation from the arc. Temperature of the charge is lower than that in the direct arc furnace. Yes?
What is stirring action in the furnace?
Your question is, what is the stirring action in the furnace?
Yes.
The stirring action in the furnace is, if we see the direct arc furnaces, indirect arc furnaces, in direct arc furnaces, since the current is flowing through the metal or charge which is placed in the furnace, due to the magnetic forces set up by this current, the complete material will be converted into the liquid pool, that is called stirring action. Whereas in indirect arc furnaces, this stirring action will not take place, therefore they will be mechanically rocked by providing the wheels underneath the furnace. So by providing the mechanical rocking, this stirring action also somehow it is possible in indirect arc furnaces. In indirect arc furnaces, no inherent stirring action provided. Furnace must be rocked mechanically, because no stirring action, must be rocked mechanically, also called rocking arc furnaces. These furnaces are made of cylindrical or spherical in shape. Electric motor is provided for rollers. Applications of these indirect arc furnaces are, they are used as melting of non-ferrous metals, but also used in iron foundries where small quantities of iron is required. Ajax vat furnace is its chief rival in the field of non-ferrous metals. So these are the applications of the indirect arc furnace. So direct arc furnaces are used in iron industries where large ratings are required, but indirect arc furnaces are used for non-ferrous materials, also used in iron industries to melt the small quantity of heating elements. So each furnace or of a ton of material converted into liquid solid state to liquid state, it needs about 500 kilowatts of power consumption. So by analyzing that, you just think over how much power consumption is required to in a furnace. So let us see how the three phase furnace can be connected internally through electrical wiring system. As electrical students, we must know how the furnaces will be connected. So this is the furnace unit, this is the furnace chamber. We have seen till now 3 electrodes are there, 1, 2, 3. These 3 electrodes are internally connected to a transformer unit. This is the transformer unit, where the transformer is connected into delta fashion, and these 3 electrodes are given a connection to internal vertices of the delta transformer or secondary winding, call it as secondary winding, and this is the primary winding. Outer side is the primary, inner is secondary winding, where secondary winding will have a number of tappings. By adjusting this tapping, the supply current will be adjusted to the electrodes, so that different temperature can be available in the furnace. And these 3 transformer primary lines are connected through the isolator to the OCB to the supply system. Therefore, the 3 phase supply comes into the isolator, where isolator is used to make or break the system, and from the isolator connected to the OCB. OCB means oil circuit breaker. You all know what is oil circuit breaker. It can be operated under all load conditions. If the fault comes, immediately it trips. So from the OCB it is connected to the primary winding of the delta connected transformer. Transformer rating will be 11 kV by 440 volts to 340 volts. So it can be adjusted up to 340 volts minimum, higher voltage will be 440 volts. So from the transformer secondary or internal vertices, it is connected to the electrodes. The electrodes are combinedly 3 electrodes connected to a horizontal rod. It is connected to an automatic control system, where for initial short circuiting purpose, this automatic control will be useful, that is automatic control for electrode movement. And this OCB and this transformer internally connected to the control panel, where in the control panel we will be having a relays. If any fault occurs, immediately this relay will sense the fault, and it will give a signal to the circuit breaker, so that circuit breaker will disconnect the transformer from the supply or from the fault. Therefore, the transformer in turn will not give any current to the furnace, thus the furnace will be protected. Now initially these electrodes are momentarily short circuited. Once they are short circuited, so arcs will establish. So due to the radiation from the arc, the high temperature produces. Due to that temperature, the metal which is placed in the furnace will be converted into the liquid stage. Sometimes this arcs also creates many number of arcs, and these many number of arcs will try to damage the this clay lining. Therefore, if that situation occurs, immediately the current will be or temperature will be controlled by adjusting the tappings of the vertices of the transformer. This is the basic circuit of a 3 phase arc furnaces. So now let us see some question answers about this chapter. In 3 phase electric arc furnace, the windings are connected in delta. You have seen the answer is delta. Induction regulator is used to control the furnace temperature, and carbon electrodes are used for low rating furnaces, because graphite is used for higher rating furnaces. Indirect arc furnaces also called as the mechanically rocked arc furnaces. So these are the various systems. We have seen how the arc furnaces will work and how to control the temperature resistance. In the next class, let us see about how the induction heating will be used in a furnaces. Thank you.